How does an inverter work? Any picture displayed in an LCD technology device requires an independent light in order to be seen by the eye. Nowadays, there are two different ways to produce that light. One is through cold cathode fluorescent lamps, and the other is based on LEDs. Firstly, we are going to see how the cold cathode fluorescent lamps backlight technology works. A high alternate current voltage produced from a continuous current voltage is necessary. Because of that, the source that makes this work is called an inverter. At the same time, it is necessary a high frequency alternate voltage to avoid interferences. And what are the necessary tools to get it? A high frequency oscillator circuit, transistors to make heavy or power work, and an elevator transformer in order to get the voltage up. Let us talk about the cold cathode fluorescent lamps. According to their size, they need more or less high voltages to operate. Their electrical resistance decreases as they heat. They eventually become less efficient and less illuminate. This can cause some problems. The high voltage is prone to cross the isolates, so there must be a short control circuit. Since they conduct more as they heat, the voltage must decrease at some point to avoid the lamp's explosion. So, it is necessary to have circuits that control the amount of voltage. And the inverter begins to operate in an intermittent way or simply shuts down if it cannot balance the brightness of a lamp assembly, since they gradually lose efficiency. It means that we have to add to the oscillator, the transistor and the transformer some circuits that control and watch over for a precise measure, so that nothing be left apart. Let's begin with a simple circuit that is used in LG Zenith brand for small TV screens. The oscillator circuit consists of the following elements: the transformers, the capacitors, the transistors. This is the primary side of the transformer, and in parallel there is a capacitor. These two elements easily oscillate or shake for a certain time when a current passes through them or is suddenly discontinued. Where would the current come from? It turns out that the circuit is powered by a 9-volt source, more or less. But in order to produce current flow, we have to push one of these transistors to conduct. Let's see that every one of them has a 680 ohms resistance at its base. Let's assume that Q51 conducts due to the excitement that the resistance 51 gives to the base. So, this is the path of the main current. All this causes the first half cycle of a sine wave in the transformer. To complete the cycle, it is necessary that the current walk the opposite way, driven by the other transistor Q52. The oscillation of this circuit is fed back by a secondary winding, which ensures that in each half cycle only one transistor conducts while the other remains cut off. And all this work reflects on the elevator secondary winding, where the lamps are connected and as a result begin to illuminate. Now, how or where the samples are taken to make the necessary controls so that the circuit works perfectly? This is accomplished by examining the ground return end of each lamp, since at this point the voltage is small and easy to handle. Besides, it is a faithful sample of the entire process. The first thing is to make pass such sample by a rectifier circuit to convert it in DC. This is possible through two different circuits, one for intensity controls and the other to detect if any lamp becomes open or disconnected. The current control circuit assumes the administration of the source that we said has around 9 volts, but can get down when it becomes necessary. For example, when the lamps are heated because, as we know, they conduct more and could burst. Let's see how it is made. This is the source that regulates the 9 volts of the inverter. The IC51 is the TK11840L that, accompanied by the Q53 MOSFET, the L52 coil, the 55 and 56 diodes, charge the C69 capacitor with a close to 9 volts voltage that may rise or fall according to the sample in DC taken from the lamps, and that comes in by its pin 1, EA in, input of the error amplifier. This terminal inverts the information, which means that if sample rises, the source will fall, and vice versa. All this makes sense, since if the lamps conduct more, their internal resistance will be less. Therefore, the sample will become higher, and the source reaction will be getting down a bit of the voltage in order to compensate.